Yeah, welcome back to our Economics of Innovation course. I think I don't have to tell you much up front. I just want to start with today's lecture on research and development. As always, just tell me if you want to have subtitles, just tell me in WebEx, okay? Welcome back to our Economics of Innovation course. Today we will cover research cooperation and research joint ventures. In a minute I will tell you more what this is about. Actually, it somehow started in the 80s, in the 1980s of course. As you see from this quote from The Economist magazine, the number of alliances between firms in the US increased from less than 800 in the 70s to more than 20,000 in the 80s. So we had a lot of cooperation in research and development. In a minute I will show you how that looked like. Of course, in a sense, from the viewpoint of antitrust authorities, of competition authorities, this is not completely innocuous. So it might be a problem if, say, Volkswagen and Ford cooperate in order to build a new or to develop a new minivan, such as they did in a joint venture in Portugal sometime, and I don't know whether it was the 80s or the 90s, when they jointly developed the Charan and what became the Ford Galaxy. And the point, of course, from the viewpoint of antitrust is if these firms together develop some product, they might also somehow cooperate in terms of pricing and something like that. But it turned out that our politicians became convinced that it's sensible to have this cooperation as long as it's restricted to research and development. And we had the Cooperative Research Act in 1984 in the US and the block exemption regulation for research joint ventures in the EU starting in 1985, and it was renewed as Commission regulation to certain categories of research and development agreements in 2010. So there was favorable policy reaction. And why was that? Now, of course, the point is there are some. Just one comment here. You on the slides you see Article 85. This refers to the EU treaty, to the Treaty of the European Union. It's now Article 101 of the Treaty for the Working or Functioning of the European Union, I think it's called. So there was favorable policy reaction. And why was that? Now, of course, the point is there are some obvious advantages from research coordination. First of all, if you coordinate projects, you avoid unnecessary duplications. If you need batteries for e-cars, for electric cars, it might be good to develop them jointly because you don't have to spend twice the amount, okay? The second thing is that spillovers can be internalized. So spillovers, in a sense, are the most or major unresolved issue in the area of economics of technology, as VIII has put it some 30 years ago. The problem is, how do you measure them? It's not so clear which company receives and how they receive these spillovers. I already made this point. Anyway, it's really important because what we see is that Volkswagen might learn from the experience another car manufacturer has in developing appropriate, batteries and vice versa. Okay. And also the same holds for autonomous driving, etc. So you might have many spillovers. The hard thing is how to measure them. But what is clear is that each or firms learn from each other, and this will be one of the most important point in our formal analysis. Another point is that, of course, from a social point of view, it is important to efficiently disseminate knowledge and information. Clearly, if we have a certain information, it should be widely used. So if we have information about how to treat COVID-19, it's sensible to really disseminate it and to spread this knowledge. And finally, of course, a problem for companies might be that to develop a certain new technology, to develop a certain new product, or say to develop a new vaccine for COVID-19, these might be very costly, very resource intensive, and financial constraints might be important. And of course, if firms cooperate, two people or two firms are stronger than one, so they might be able to overcome these problems. Yeah, I just want to give you a few examples here. What is interesting here, you might have heard of the fuel cell technology, an alternative to the electric car in a sense, based on hydrogen, Wasserstoff. And what you see here was a joint venture between Daimler and Ford to produce or to develop this fuel cell technology as, say, an engine for cars and as an alternative to the combustion engine. Okay, the interesting thing is that I think this started about in 2011 or 12. This project it was abandoned in June 2018. So you see, first of all, you can get research cooperation because it's even, for instance, too expensive for Daimler, for a large company like Daimler or like Ford alone to develop such a technology, and it might still run into trouble as it turns out that it was too complicated. Even though Daimler says it still proceeds with the development, it's not clear where this will end. Okay. Yeah, and what you see here is just some statistics. We see that many new R&D partnerships started here at about 76. At the end of the 70s, you really had a strong increase in these R&D partnerships. And what is interesting, it seems somehow have to been almost a fad or fashionable to start R&D partnerships in their time. There are recent publications like a one by Tomasello and Napolitano and others in industry and corporate change, where we speak about the rise and fall of R&D networks, and they argue that there might be a fall after these peaks sometime in the 90s. And what they say is that it's not that R&D cooperation became less important, but just R&D cooperation for its own sake, just to have some cooperation, that in a sense became less prominent. Okay, you only now cooperate in order to really achieve something specific, not just in order to cooperate. That's what's also somehow coming up from this diagram, because here you see, you might get the impression that it's really high-tech or high-tech industries where R&D cooperation is particularly important. And in the 80s and so on, you also, here it's still the 70s, you even had medium tech or low tech firms cooperating. It seems that it's now more something about high-tech industries. And finally, as you might also guess, and which something which might be interesting with respect to our case study part on the pharmaceutical industry, you see that the pharmaceutical industry, this would be this here, really increased a lot in that time. And it's also the IT industry, information technology, where you see many R&D cooperations and partnerships. Okay, somehow it's not so unexpected what we get here. What is really interesting, I think, in particular in these times where we have a lot of research going on in the COVID-19, in the corona area, you see that in the pharmaceutical industry, you have really many partnerships. So Glaxo, one of the largest, or GlaxoSmithKline, one of the largest pharmaceutical companies, also like Pfizer or Novartis and Hoffmann-La Roche, they all have really a large number of partnerships. And these partnerships might be with other pharmaceutical companies or with smaller biotech companies. Okay, here you see many. It's from a nice publication from Baker, Gibbons, and Murphy. And what you see here in the following slide, so the previous slide covered the pharmaceutical companies. Okay, these are the large ones which then do the clinical studies and so on. We will learn about more once you present that in our case study part. And the other part are the biotech companies. Like yesterday, it was in the news, this CureVac company in Tübingen, which tries to develop a vaccine now for COVID-19 or against COVID-19. And here you see our pharmaceutical, our biotech companies like Genentech or Genzyme, which also do something like that. I don't know whether Amgen is, for instance, some of these companies. The point of these companies, like the ones mentioned here, or CureVac, is that they are really scientific laboratories in a sense, which develop some basic ingredient and then if they cooperate typically with the large companies in order to start this development process, to start the clinical phases and so on. Okay, hopefully one of you or some of you in your talk also, once you present these case studies, can perhaps say something about these partnerships. And what you see here is really, it's really an amazing network of partnerships, of strategic alliances among these top pharmaceutical companies and the top biotech companies. Everyone almost cooperates with everyone. Okay, and of course that always relates to different kinds of therapeutic groups, like cancer, a drug like thrombosis drug, and so on. Okay, and you have insulin drug and so on. I don't know. Here's Lilly. They certainly, I don't know whether it was Genentech. Genentech is missing here. So, but they all somehow cooperate with each other, and you see cooperation always looks, once you see such a picture today, you'd always think of a virus. It almost looks like a virus. Here you have this C, perhaps I might even, I don't know how well you can see that, but I might even try to enlarge it here. So this would be the core hub. You see here the large ones, which are in a sense, the so-called hubs, and to these hubs are connected with each other, and they are also connected with what is called intermediate hubs, and then you have also some independent groups or loosely connected groups. So the point is, and this is real network structure, so it's really that cooperation is so important. Of course, if you're an antitrust economist or a competition economist, you always would just say, "Oh, wait, this looks very dangerous, because how could we expect that they compete toughly against each other if they cooperate on research and development?" Okay, and that's of course always a point of concern for antitrust authorities. But still, at the same time, we know, and that's what I'm going to show you in a few minutes, in a few slides also, that it might be really, from a viewpoint of social welfare, a good thing if even competitors cooperate. Okay, that's what we are going to show. And there must be something about cooperation if it can be seen everywhere. Okay, now here just what are the determinants of such R&D cooperation or of the formation of research joint ventures? I briefly managed that. This is from a survey of Nick von Ortas and other authors here. Of course, the most important thing is, or the question is, whether you can share cost and therefore save R&D costs. And you also reduce, and that's closely related, you are able to reduce this duplication of effort. And of course, you reduce uncertainty and share risk, because you're not the only one who has to bear the risk, you share it. Okay, and you internalize spillovers. That is, it's now obvious that if you know someone else, the other laboratory knows something, and you can learn something from that, and they can learn from you. It's a good thing if you do that rather proactively, and so to increase both your productivity in research. Of course, here access to finance might be better, and you can just go on with your R&D effort. I think that was just what the German federal government announced, in a sense, yesterday, that they want to pay 300 million, or I don't know whether it's a grant to this QVAC. Of course, you do not always want to have the government involved, and perhaps it's better if you have another company which just joins then forces. What is also important is if you are, for instance, an automotive firm which doesn't have any idea about how to produce a battery, it might be good if you join forces with a battery producer, and therefore you get access to complementary resources and skills, okay, and vice versa. And then you might also have research synergies. Yeah, that's again related to R&D cost sharing. So these points are somehow overlapping. If you have existing resources, the further development of resource base, that's again clear. You want to have, closely related to that point, you also want to have the respective skills and to be able to further develop, say, your batteries and so on. Strategic flexibility, yeah, that's catch-all term. Of course, that's always good. What is more interesting in a sense is promotion of technical standards. If you want that your technology becomes the new standard, look, I don't know how many years, 20 or 30 years back to when the CD was introduced, the compact disc. Perhaps it was a good idea for Philips to join forces with Sony in order to develop that and promote that technical standard. Of course, market power is something which you as a company might like, which antitrust authorities don't like, but in the end, of course, that might also be some argument, because you reduce competition, and if say all the German car manufacturers do a joint venture on something on like batteries, battery production or something like that, they might get more political support than if just one does it. Okay, so we have many different arguments here or determinants of formation of R&D, and what is closely related is, of course, why are these companies then doing R&D? What are the objectives? Okay, and of course, here the one I already told you that this is both an incentive and an objective. You need access to complementary resources and skills. Think of our car manufacturers, which need access to battery technology. So that's why we form joint ventures. Okay, and it might also be important to keep updated with major technological developments. So if you're able to like cooperate with one who is leading in that field, of course that benefits you, and it also allows you to learn about technology, and that's what we already had. So you see there's a lot of overlap here with R&D cost sharing, and so the expected and realized benefits here then, of course, are hopefully you get new knowledge, okay? You can develop new products, and you can improve your capabilities, okay? Your in particular, so your engine unit or whatever it is, okay? So that's in a sense a background, and here some success factors. Okay, that's also very similar to what you are doing. You form working groups. What is in such a working group to together in order to solve together the problems? It really makes only sense if all of you have absorptive capacity. So if you work together, you should understand what your colleague does. Okay, and the point is, the more related your research and your capability is to what the other has, the more productive you will be. And that's similar to R&D. So if you have a company who already has a certain idea of how the batteries should work and how you could integrate them into your car, the likelihood of success is much higher than if you have a company which hasn't got any idea about how to build an electric car. That's what you perhaps see now at Volkswagen. They have large problems right now with their newest models. Okay, perhaps they still have too little absorptive capacity. Yeah, and the lower the problems of knowledge appropriation will be, the more easy it will be for you to handle this new information. Okay, and the higher, of course, it's always good if you have higher effort of the specific business unit involved in that. And concerns, there are also concerns, but that's pretty much what I already told you. There might be serious adverse effects on competition. And another point, that's a point which also came up once we discussed R&D or patent races. It might be a good thing to have parallel laboratories, or to have two laboratories, because you might then have a bigger chance to get a success. Okay, if you have a too limited approach, if you limit duplication, that might hurt or delay innovation. Okay, because if you choose to proceed only in one direction and it turns out that this is the wrong direction, you have a problem, because then you have to start anew. However, if you proceed into two directions at the same time, the likelihood and the speed with which you will develop the new technology is larger. Okay. Yeah, given this long introduction to the problem and to important effects, I just want you now to give you a short taxonomy and in a sense, define some terms which are important here in terms of R&D cooperation. Cooperation or coordination might be ex ante or information sharing ex post. Just think of our fuel cells here example. So what Daimler and Ford did, they set up an R&D laboratory. They decided on how many engineers to hire and so on, and how to cooperate. That will be coordination ex ante. It could, however, also be information sharing ex post. The different companies then run their own R&D laboratories, try to find something out, and once they find something out, they make an agreement to exchange this information. Okay, that would be information sharing ex post. And in terms of spillovers, there is an interesting example from the US. At some time, I don't know, it was perhaps in the 1980s or something like that, or even earlier, the production of steel changed. Previously, or in former times, it was really huge plants, and then so-called mini mills with electric production of steels became available, and this was, in a sense, a new way to produce. And the workers needed training. And what these firms in this mini mill industry or the steel industry did, they exchanged technical information and they trained workers of competing firms. in the use of these specific equipment. Okay, so you had a spillover. One company learned from what the other company knew, and it was related to the input, because the worker, of course, is the input in that process. It might also be related to the R&D output. That's like you share the knowledge, like in the form of licenses or of patents. Okay, or of solutions for a certain say production process and so on. And we will discuss that as well. Of course, cooperation might be in very different forms. It might be informal, or it might be a formal joint venture, like the one with Daimler and Ford, with a clear governance structure and so on. Okay. And of course, what you have here, otherwise you have to solve, if the structure is not so clear, you might have to solve principal agent problems, because perhaps Daimler wants that you do research in a certain direction, Ford wants to have to do research in another direction, Daimler wants to conceal some information, and vice versa. Okay, that's what might happen here. And of course, the point, or what is in terms of antitrust and competition economics important, is how does competition in output market look like? Are these companies active in very separated fields, like you have a battery producer who produces batteries, and at the same time you have a car manufacturers, completely separate, or might even be complements, okay? Or if you think in terms of computer hardware and software, where you certainly have complements, and they might form a joint venture to produce some next generation of microprocessors together with the appropriate version of the operating system, okay? It might also be substitutes, like in this case of Ford and Volkswagen I gave you. Okay, we might also consider this and inquire into the importance of that. Okay, how important is it, and what are the dangers? Okay, and competition then might be either perfect or imperfect, or even collusion or tacit collusion. And what we want to do right now is give you a formal analysis of such a research cooperation. That all started with a paper by D'Apremont and Jacquemin in 1988 in the American Economic Review, called Cooperative and Non-Cooperative R&D in Duopoly with Spillovers. And the question here was, is it a good thing to allow competition among competitors, not competition, to allow cooperation in research among competitors? Okay. It will become clearer in a second why or how this cooperation might look like, and why it might be a good or a bad thing. Okay, that's what we are doing. The version I present here is closer to a paper by Morton Kamian and others from the American Economic Review in 1992, Research, Joint Ventures and R&D Cartels. So what we do is very similar actually to our Dasgupta-Stiglitz model we did in chapter 3. Okay, we have an oligopoly, here a Cournot oligopoly. We assume for simplicity our linear demand function, or actually it's the inverse demand function here with aggregate output Q1 plus Q2. And we have a certain R&D level technology. This is very similar to the one we had in other parts, okay? Also like in the Dasgupta-Stiglitz model. The point is here, you start with a base level, and by investing in R&D, you can reduce your cost, okay? And X here, I think X, the capital X, is what we call the effective R&D expenditure. Okay, what does this mean? Now, if we have two firms, if firm 1 invests X1 in R&D and firm 2 X2, so the point is that the effective R&D expenditure of firm 1 might be just X1. Okay, if there is no spillover, however, of course, it's clear if it forms a research joint venture, it would be X1 and X2. The spillover then would be 1, because you would just work together and of course get then more R&D input. However, this would be then a formal cooperation, but typically it's also that Samsung learns something from Apple and vice versa, and Huawei also learns something from Ericsson and from Nokia and so on. So you have certain spillovers here, and of course you got some spillover theta. If you have a competitor who works on the same in the same industry as you and invests in R&D, you have a chance that you gain from what your competitor invests in R&D. Okay, and here this is what we call an input spillover, because here X1 is just the R&D expenditure, so how much you spend on R&D, how much you invest in terms of engineers, of researchers, of scientists, and so on. And what is clear, the spillover should not be larger than 1. So if you form a joint venture, for instance, you would expect to have this spillover 1, because each euro Daimler spends and Ford spends in this fuel cell research joint venture, of course, will lead or will help to reduce R&D cost in this, or not R&D cost, but to reduce production cost here due to this R&D technology. As always here, we have some process innovation, okay? You should know that by now, because process innovations are always easier to deal with. Okay, now here, hopefully this became clear. Okay, with this input spillover, which is of course, or was in a Dasgupta-Stiglitz model, simply zero, and with perfect R&D cooperation called a research joint venture, it will be 1. And even if you don't cooperate, it might be something between 0 and 1. You just learn from others. Okay, and we here just use a specific functional form in terms of the cost reduction technology. That's what we also had before. It's just these concave shape here, which then gives rise to the if we have here some x, it just, and here's a c bar, it just gives rise to this, oops, convex shape here. Okay. Okay. How does the profit of the firm look like? It's very straightforward. That's what we always had. Here, this is nothing else than inverse demand. So this is our price, depending on aggregate output, times the output of the firm, Qi. This is nothing else than the realized marginal cost, in a sense of firm I here. And the realized marginal cost depend on its own R&D expenditure and on its rivals' R&D expenditure, xj, via this theta spillover parameter. And of course, if it invests something in R&D, if it has a certain expenditure x, it has to pay that. Okay, standard. And of course, now we just need to make some further assumptions. And the first assumption is that we have simultaneous choice of R&D and output, and we do not consider any R&D cooperation. So they just decide independently, these firms, independently and simultaneously, and R&D on R&D and output. And this is just the setup we used in Dasgupta-Stiglitz, and this has been applied to research joint ventures by Leahy and Neary in the American Economic Review 97. And what we are doing, and that's what you already did actually similarly in chapter 3, that's why I don't want to spend so much time. You just derive the first order condition. Okay, so here we take the derivative with respect to Qi and the derivative with respect to Xi. We get 2 first order conditions. These are straightforward conditions. Set them equal to 0, apply symmetry, and get something. Okay, for the moment you should just believe that this is the right solution, and of course at home you should check the results. Okay, and so here what you see, or what is very interesting here, you just get some level Q, and the level Q is independent of theta. So the spillover does not matter. However, the X R&D expenditure depends on a theta parameter. Okay, yeah. So from the Dasgupta-Stiglitz model, we know that firms are cost minimizing. So and what we see is, if we get a higher spillover parameter, it's clear that X will decrease. And on the next slide, we see why this is so. Here, the effective R&D expenditure, that's actually what enters our R&D function. Effective R&D expenditure is just 1 plus theta times X star. This is also independent of the spillover, and that just means the firms are just cost minimizing. We see each firm has, irrespective of the spillover, a certain output Q. Okay, and the only thing it does, it minimizes costs producing this output X by choosing X. And the point is, the X which is really important then is the one which takes into account the theta. So it's the capital X, the effective R&D expenditure. And the nice thing the spillover does here, and that's why it's so important, is that it just reduces the cost of production. You have the same cost reduction. That means in terms of production cost, and therefore you have the same output. But now you have lower R&D cost or lower R&D expenditure. Okay, you don't have any further effect. So yeah, I think that's about it. So R&D just minimizes cost here, and if you get some spillover, that's like manna from heaven. You get it for free, and that's a good thing. And so you see here a higher spillover. Is just good in terms of profits. Later on, I will just show you a simulation where you see that in more detail. Okay. Okay. Before I move on to the sequential choice of R&D and output, I just make a short break to ask for your questions in WebEx. Okay, now we move on and hope that everything works. The more interesting case here, and in a sense the standard case assumed in this literature by D'Apremont, Jacquemart, Kamian, Müller-Zhang, and so on, and others, is what we call the sequential choice of R&D and output. And again, we start with no R&D cooperation. Here we think, or here we consider a so-called two-stage game. What does a two-stage game mean? It means that we have a first stage where the firms choose a R&D expenditure simultaneously. Like think of the Ford and Daimler, they choose the R&D expenditure, or Ford and Volkswagen on their minivan rival Charan and Galaxy, they choose the R&D expenditure, and only once they have developed a new product, they have developed a new process, they start competing. Okay, only after observing the rivals' R&D expenditure, and therefore also the outcome, of course, both firms simultaneously choose their output. And this is now different, as you will see, because now you have the possibility to engage in a commitment, in a sense. You can make a commitment, you can invest a lot in R&D. What does that mean? You signal the other, you will have very low cost, and you will produce a lot, okay? And that's what we consider here, okay? You can make yourself strong in the output game by investing a lot in the R&D game. And so what you do, how you solve such a two-stage model is just backwards. You derive the optimal output given the R&D expenditures, and then having that, you derive the optimal R&D expenditure, taking into account the effect on the second stage of the game. You will just use here the so-called reduced profit function. For all of this, you will have a problem where you can easily, or hopefully easily, solve that in terms or with specific given parameter values. Okay, and how to solve that? And now this is really all standard. It's what we, in a sense, did all semester long here. How do we get this equilibrium in the standard output game? It's a standard Cournot equilibrium with linear demand and constant marginal cost. The second stage game is just for given x1 and x2, then it's just for given c1 and given c2, given marginal cost. And you will remember that looks very similar to the solutions we had in the very beginning, where we had, I don't know, q was something a minus 2c1 plus c2 or something. You probably cannot read that right now over 3b. I think this is exactly, I should really denote it nicer, or should jump to the respective. I think hopefully I don't get it wrong here, but it looks like we have here a minus 2c1 plus c2 over 3b. I think that's it. And that's what you see here as well, because here this 2 with one of the c bars gives you c1, and the second c bar, of course, would be got away, because here we have a minus c bar. With this here, this would be c2. Okay, and of course, analogously for firm 2. So it's straightforward. Okay, and however, what is interesting here is that the spillover parameter, of course, the spillover parameter, and therefore the rivals R&D expenditure enter your output. Okay, what we see here is if x2, given some spillover parameter, just say 1/2 or something like that, if x2 increases, that would, in a sense, increase or decrease your cost via the spillover parameter. This is a good thing, okay? At the same time, of course, it would make your rival stronger. That's here because it has in itself lower cost. And of course, your R&D expenditure is good in the sense that it reduces your cost, but in a sense, it's also bad. And I have too many errors here. It's also bad because it reduces your rival's cost as well. Okay, that's what we have here. So Q is a function of x1 and x2. That holds also in the standard Dasgupta-Stiglitz model. If we look into the sequential choice version, which we only do here in this part, but what we have, what is called, I think by Kamian, Müller-Zhang, the competitive advantage externality, it reduces the incentive to. Excuse me, I just have to get it right. Increase, so there are two effects of an increase in my R&D expenditure on my rival's output. the rival's output increases because it reduces my cost. This would be the competitive advantage externality, and the strategic investment effect, because that's bad because I get stronger. Okay, so we have these two effects. That's what I already told you. I just wanted to give you this terminology. And in the notes, you also have this quote from Luckingbloom and van Reenen that R&D generates at least two distinct types of spillover effect. The first is a technology or a knowledge spillover, which may increase the productivity of other firms that operate in similar technology areas. This was most clear in the simultaneous choice setup. It was clear the spillover is a good thing because it reduces your need to invest in R&D. That was this, say, technology spillover, and the other thing is, and that's what would have been here, the competitive advantage externality. This is a slight misnomer, I think. And the other thing, it's also a negative, just to get here, and the second type of spillover is a product market rivalry effect, okay? And this product market rivalry effect has a negative effect on a firm's value. That's exactly the point here. That's what you don't want. You don't want to make your rival stronger, okay? If you, as firm one, invest in R&D, it makes, and that's this effect, firm two stronger by this spillover effect. And this will be important then, because it really depends on the theta parameter, on how strong the spillover is, which of the effects dominates. And of course, now given that we have our Q1, our Q2, we simply or straightforwardly can substitute that into the profit function and get the so-called reduced profit function, which is now only a function of x1 and x2. Okay, no more quantities here. This is the reduced profit function. Again, you should just check it. Okay, and what we do next is, of course, here we already determined the optimal Qs given x1. Now we and x2. Now we can determine the optimal x1 and x2 again in the respective Nash equilibria. We derive the reaction functions or just the first order conditions. Take the derivative of this profit function 1 with respect to x1, and then the derivative of profit 2 with x2, and solve for the symmetric equilibrium. And of course, always you should check what I calculate, and actually you will have the opportunity to check that not for these general parameters, but for specific parameter values. So now, what is our symmetric equilibrium? We just solve for x. This is now non-cooperation, okay? Non-cooperation. And what we see, first of all, is of course now our spillover parameter matters, and it does not. Remember, that's what we also had in the Stiglitz model. It does really affect the spillover parameter, also the effective. I don't know where I have this. The effective R&D spillovers. What we can show here is that the increase in spillovers reduces firm R&D expenditures. You would just take the derivative with respect to theta. You'll also will see that in 2 minutes in some simulations I show you. Okay, and what is also important here, if we compare that with our previous case where we had simultaneous choice, you will see that you invest much more. You are more aggressive. You want to have cheaper or lower marginal cost, lower production cost in order to be stronger and to get a better market position. Okay, that's what we have. I think that's one of the results I wanted to show you. And I just wanted to move on. And that's what we see. Firms invest more in R&D in the two-stage game. Oh, actually, I was too quick here. It's really important to have these parameter theta. So what we just compare is this here. The parameter theta is important. If we have low R&D expenditure, we will have, if we have a low spillover. We have a high R&D expenditure if we have, and higher than in the no commitment case in a one-stage game. And if we have high spillover parameter, we have lower R&D expenditure. Perhaps it's best here. Here I just also calculated the equilibrium output. You see now the equilibrium output depends on a theta. And just check it. If theta increases, this term decreases, becomes smaller, and therefore, I'm now too puzzled here, becomes smaller, and that becomes smaller. We subtract less, so this becomes larger, hopefully. Right now, I'm really puzzled, I think. So here you see the error is just in the wrong direction. Okay, that's I don't know why. It probably was too hot last year as well. Today seems to be too hot for my computer, so that the CPU really has trouble to do all what OBS requires in terms of streaming. But anyway, so hopefully it's clear. If you you probably cannot see that now, but you will see if theta increases, the whole term decreases. Okay, that's what we see, because theta enters the denominator with minus times minus, which is a plus, and if I increase the denominator, the whole term, of course, decreases. I think I should make a short break here so that I can really increase and spill over decreases output per firm. Okay, if you increase theta, that becomes smaller, so you subtract less, so the denominator becomes larger, and therefore Q becomes smaller. Now I think I got it. So increase in spillover decreases output per firm, and the increase in spillover also decreases effective R&D expenditure. That's what we see here. Of course, you have to take the derivative. You don't see it immediately, but I just want to show you that here in terms of the diagram, where I have more in it, but I think here it deserves it. So what we compared is really this thing here with this thing here. And the point here, the red line and the blue line. And what we have here in terms of the effect, if theta is 0, you see that the investment in R&D is much higher in the sequential choice and in the commitment game than in the simultaneous game. Because here you really have what we would call a prisoner's dilemma, because you, in a sense, both overinvest to be tough, and that's only good for consumers. You are in a prisoner's dilemma, as you will see here in terms of the profit, where you have the same thing. You see profit is much lower in a sequential game, in a commitment game, than in a simultaneous game. Okay, and what is now the importance of the theta parameter? Yeah, now if there is no theta, if theta is 0, if there is no spillover, I have to say, if there is no spillover, the point is that then only this commitment effect is strong. You want to overinvest, you want to invest to be strong. But the point is, if theta increases, what does your investment imply? It implies that you make, by investing in R&D, you make your rival strong. In the extreme, you make your rival extremely strong. And that's what leads you to invest less in R&D. Okay, and here less in R&D means you actually invest less in R&D, even though the spillover is higher. The higher spillover does not overcompensate or cannot compensate for this strategic effect. That's different in terms of the simultaneous game. In the simultaneous game, you see your R&D investment also goes down with theta. Okay, that's a blue line, but it just goes down so that the effective R&D expenditure stays the same, and therefore cost stays the same, and therefore output stays the same. And of course, in terms of profit, it's just good, because output stays the same, price stays the same, operating cost stays the same, but you save on in terms of R&D expenditure, of R&D cost, and therefore you get the increase in your profit. Hopefully it's clear. You can just think it over. I jump back again to the previous slide and make a short break here in order for you to give you a chance to ask some questions. Okay, also short break, and same as last year. Ask for questions. Okay, we move on here. Yeah, probably I was too quick for you to ask questions. Perhaps you listen to this or watch this live stream then not at 1.5 speed, but at the usual speed. So Anyway, hopefully it's clear. Nevertheless, the point here is that it's just the standard kind of Cournot model. Okay, what we did at really great length in the Dasgupta-Stiglitz setup in chapter 3. And so the only difference here now is we use sequential choice, okay, rather than the simultaneous choice of R&D, and we account for these R&D spillovers. And actually, it's here an input spillover. That's what you see. It just increases your effective R&D expenditure. That's what we had on the previous slide. Okay, that's what we have. And I already tried to explain to you the different effects we have. First of all, or we have always these two effects. Okay, these two effects. On the one hand, you love to have a spillover because you learn from that. And on the other hand, you hate the spillover because your rival learned from that. Of course, it would be a good thing to have an asymmetric from your viewpoint, but not from a society viewpoint. But anyway, so we will just move on in a sense to solve this problem, because if you know your rival gets something from you anyway, you might just cooperate in order to do that efficiently. Okay, and we now look into two different kinds of research and development cooperation. The first one is a cooperation where firms choose their R&D expenditure together, such that industry profits are maximized, but our spillover stays the same. In the next the next point will then be to look into what we call then research joint ventures. There we both cooperate on setting the R&D expenditure, and they maximize the spillover. That is, they set the theta to 1. Okay, now what we can do in the very beginning, or what we see in the very beginning, or what we can immediately conclude in the very beginning, if these firms cooperate in terms of their R&D expenditures, and if they say, okay, think in terms of our fuel cell argument, of course, Daimler and Ford then jointly determine how much to invest in R&D. Of course, what will their objective be? It will be to maximize their joint profits. Okay, and of course, will these joint profits be higher than under no cooperation? Yeah, of course it must be, and the argument is a very simple one. It must be because they could just do the same as we did without cooperation. So they can always at least set or guarantee the previous the profit without cooperation, and by cooperating they can increase their profit. Okay, and that's what you will see here. Yeah. Now, again, same thing, second stage competition in the quantity game. Maximize now here this joint profit by choosing X1 and X2 and solve for the symmetric equilibrium. Okay, straightforward. And again, check this. You get here that the cooperative R&D expenditure is this, and again, it depends on the theta parameter. Okay, and the point is, what we again will see here, for high values of theta, the positive externality of spillovers dominates the choice of the firms. For low values, the negative effect of increased competition dominates. So what this helps you here, if you maximize joint profits, it helps you solve this prisoner's dilemma scheme. Okay, and that's a very important result here. That's what you will see for theta, and you will see it turns out that 1/2 is a very important value here, because for 1/2 everything, for spillover parameter of 1/2, almost every solution is identical. The cooperative solution leads to the same R&D expenditure as a non-cooperative solution. And here's what I just told you. For low values of the spillover parameter, R&D cooperation leads to lower R&D expenditure than non-cooperation. For high values, the opposite holds. Okay? For low values, you see spillover is not important anyway. Then this cooperation is actually just a cooperation, in a sense, a cartel to reduce R&D expenditure. And of course, it's obviously or clearly obvious that that's a bad thing from a viewpoint of social welfare and of antitrust. Okay, and finally, we look, before I go on, interpret that once again in terms of our simulations. I just introduced to you these RJVs, okay, research joint ventures. What do we mean here? That's what I already told you. Firms choose R&D expenditures to maximize industry profits, and they internalize all spillovers. That is, they set theta equal to 1. In terms of our Daimler and Ford fuel cell research joint venture, of course, it's clear that then they just start a joint laboratory, and all people who previously were employed with Daimler and with previously were employed with Ford, they now cooperate and they exchange all knowledge, just as if the other employees from the other firm were just employees of their own firm, which are actually they are if it's really a formal joint venture. Okay, should be clear that then we just if both have 10 engineers, it's just as if you had 20. So the spillover is 1. Whereas if you only have cooperation, but disjoint R&D laboratories, you might have, say, a spillover parameter of 0.2. So you only get 12 in terms of effective R&D expenditure. Okay, what is clear here? Of course, profits also should be larger than with R&D cooperation, and of course then also larger than with non-cooperation, because you just get more of the same. You get the θ1, okay, and that's what you will see here. The solution is again very similar. Of course, here you don't have any theta because we assume that theta is equal to 1, okay, and what we get here is that we always, for all theta, of course, the theta only applies to the non-cooperative solution. It's always that the research joint venture leads to more R&D, expenditure than non-cooperation. And for instance, Peppel, Richards, and Norman in their textbook conclude from this result that RJVs should be encouraged. So RJVs lead to higher R&D expenditures than R&D competition. They are beneficial for society since output and profits are greater and prices are lower. And that was pretty much the result already of the first paper by D'Apremont-Jacquemin, and that already benefited this positive view of politicians or antitrust authorities on that. And that's where I get back to my previous simulations here. I already explained the blue line and the black line. What you see. I just wonder, need to higher R&D expenditure. This must be higher effective R&D expenditure. Okay, that's what you will see here. Why is it higher effective? Because so here in this point X, you have a spillover of 0, whereas here with the RJV, you have a spillover of 1, giving you effective R&D expenditure of 2 as well. Okay, of 20,000 then. Hopefully this is clear. So here spillover is 0. So if you have R&D expenditure of 20,000 in non-cooperation, this is effective R&D expenditure of 20,000. However, if you have R&D expenditure of 10,000 of each firm, it will be an effective R&D expenditure of 20,000. And for all other values, of course, it's large. Only here in the limit, it's the same. Okay, now the point here is, and what I want to tell you is, first of all, this comparison between the cooperative and the non-cooperative solution. And here you see, as always here, the θ1/2 is really the key threshold. It's really the key threshold. You see here, for low values of the spillover parameter, cooperation just leads you to reduce R&D expenditure. Okay, reduce R&D expenditure because you can now save by joint profit maximization this prisoner's dilemma. And I just jump forward to slides here, to these slides with the profit. You see with this joint profit maximization, you have much higher profit than if you have unilateral profit maximization, if you have non-cooperation. Okay, and only here, as always here, profits are the same for theta equal to 1/2. But apart from that, it's always higher for the cooperative solution. And what you also see is that it's always best to have research joint venture. Why? Yeah, here you don't run into this. And why is it also good from social point of view? First of all, why do you get higher profits? Now, of course, you can always get the same as here, but you get, in a sense, this free lunch as you have a spillover parameter of 1. Okay, and only here is no difference at theta equal to 1, because here it's clear it's the same solution because you cooperate and have a spillover of 1. Okay, and why is it good from social point of view? Yeah, because you have the highest Q. Okay, here you have the highest Q. You see for theta equal to 0, theta equals 0, it's the same. And of course, this will probably, I didn't calculate it, but it will be probably a consequence of the linear model here, that it's exactly the same. But then it's always, you have always highest output with RJV, and therefore always the lowest price and the highest consumer surplus. So highest profit and highest consumer surplus. This is really a good thing, this research joint venture. But what you also see here, allowing research cooperation without this internalization of the spillover is really a bad thing. In particular, or it's a particularly bad thing, I should put it like this, if the spillover is low, okay, then it's really a bad thing. Because that means that you give the firms an opportunity to solve their prisoner's dilemma. Of course, here to the right of the point of 0.5, the threshold 0.5, from a viewpoint of the firm, these spillover, this negative effect of the spillover by making the rival stronger is important, and therefore you can allow it here, because if the spillover is very high with no cooperation, you will see really low, and that's what you probably even see here better, with a very high value of theta, you really see very low R&D expenditure because you don't want to make your rival strong. You know, if you increase your R&D expenditure by €1, that reduces your cost by something, but at the same extent, it reduces the cost of your rival. Okay, and that's a bad thing. And hopefully it became clear right now why the theta of 1/2, which is special for these, of course, this linear case, but why there's some threshold is important in terms of the theta. Okay, because for low values of theta, it's always that non-cooperation leads to the prisoner's dilemma and over-investment from the viewpoint of joint profit maximization. But over-investment from the viewpoint of joint profit maximization is good for consumers, because it leads to high R&D and to high output, okay? And here cooperation, simply cooperation without internalization, okay, would lead to a bad outcome, okay? And the point is, if internalization is not possible, the question is why it should not be able to be, but then you would only allow research cooperation if the spillover parameter is really high. Okay, I think this should be about it. If there are any questions, we might discuss that later on, but I think you will have just probably an assignment where you do very similar thing. The important point is that you really get these two effects right. Here we are. That was his lucky. So here, these two distinct, the one the technology spillover and the other the market rival spillover. And it's a strategic investment effect or competitive advantage externality. So here increase, so what is very clear is that with low spillover, this strategic effect is very important, okay? And with no cooperation, it leads to overinvestment and to a prisoner's dilemma. Yeah, that's what I wanted to tell you here. So here, this low profit here is a good thing from the viewpoint of consumers, because that means overinvestment in R&D from the viewpoint of joint profit maximization, because due to the strategic effect coming from the commitment possibility. And on the other side, here with the high phi, it's in a sense a bad thing. With the high theta, because it means that you don't want to invest because you give away too much knowledge by the way of the spillover. This is the second effect here. Okay, this would be this technological spillover effect, not the market rivalry effect. Or here actually, it's always a mixture, but the point is, hopefully you got it here with the R&D effect and with the effect on the other costs and with the spillover effect on the other cost, okay, that's a bad thing, and you make the rival stronger, and on the other hand, the effect from the commitment. Okay, so actually, okay, I make a break here. I think OBS needs a break and my CPU needs a break. So I move on and show you some part of my own research I did on that topic. Actually, that was what I wanted to tell you about that. Actually, then the first time I think I gave this lecture some 15 years ago or so, it turned out that I just wanted to generalize this story and use the same kind of demand functions we used in the Dasgupta-Stiglitz model, namely the isoelastic demand function. And it turned out, once I calculated that if the elasticity of demand is 1 or smaller, which is perfectly okay in order for an equilibrium to exist, it turns out that in this case, both R&D cooperation and research joint venture enable the firms to implement the collusive solution in the quantity game. So we get this problem we have in a sense here. Here you just don't you just don't like what we had here with the R&D cooperation. You just don't invest a lot. Okay, you don't invest a lot and make a higher profit, and you get then high prices. That's what we have. And that's in a sense also what Stephen Martin said, that this might provide you with an opportunity in a sense to also collude in the output market. Here it's not even necessary that you collude in the output market. With this kind of isoelastic demand, you would just invest as little as possible into R&D, and that would give you a very, very high price. And that's how you end up with realizing the collusive situation. Just you can download this and look into it if you're interested. Okay, so now I'm done with the theoretical analysis here, and I just want to draw your attention to a paper by Ulrich Kaiser, published already some time ago, where he takes these theoretical models to the data. Okay, he makes an empirical test of these models explaining R&D cooperation, and he does that based on data from what is called the Mannheim Innovation Panel, which is run by the ZEW, the Zentrum für Europäische Wirtschaftsforschung, Center of European Economic Research in Mannheim, based on regular surveys for many German companies. And the interesting thing here is that he really produced hypotheses based on these data and then checked them for I don't know how many firms from the German service sector. So he derived that similar to what we have, based on mainly the paper by Morten Kamian and others. And there's a slight problem or a slight difference, because they also account for oh, I just have to jump back because I didn't read the hypothesis I wanted to explain right now. So here, just to show what kind of, or how he came up with the hypothesis, here he says that an increase in spillover tends to reduce the incentives to collaborate in R&D. And this is what we typically much have here. So here the red line is, oops, sorry, that was again wrong. The red line is what you have here in terms of no cooperation. And you see the difference is largest here between the cooperative, or actually the cooperative solution even up here, and the non-cooperative solution for small values of theta, apart from this small part up here with very high spillovers. But here you see this difference decreases. You can see if I show you my fingers, but here this difference decreases with a higher theta, okay? And here with theta equal 1/2, it's 0, and then still it decreases with respect to here the RJVs. And that's what in a sense is this first hypothesis about the second one, which and here he finds that you really have positive effects of what is called horizontal spillovers. He also considers vertical spillovers, but that's nothing we consider here. Vertical would be just between, say, a supplier of batteries and the core manufacturers. And the second thing here is that research efforts, this hypothesis 10, that research efforts are larger under RJVs than under research competition, provided that spillovers are sufficiently large. Here we have to take into account that he has some trouble with implementing these distinctions between research cooperation and RJV, because he can only observe whether these firms cooperate, but not whether they internalize the spillovers. But here, in terms of these hypothesis 10, research efforts are larger under RJV than under research competition, provided that the spillovers are sufficiently large. And that's what you see here. This is exactly here if you compare, for instance, this non-cooperation. For low spillover, it's larger. For high spillover, the cooperative solution provides higher incentive. And that holds even for RJVs. Okay, you see the internal or the individual R&D expenditure would even be higher for non-cooperative companies. given the theta is very, very low. Okay, and hopefully this matches what I said, yes. Okay, here research efforts are larger. Or larger under RJV, provided that spillovers are sufficiently large. Okay, we could immediately, or we could calculate in terms of the non-cooperation versus cooperation, the spillovers would have to be at least 1/2. In terms of the non-cooperation compared with the RJV, it would have to be at least this value at about 0.3. Okay, so that's you see how we can come up with hypotheses, and here is what you see. What he finds out is that research efforts are larger under if you have an RJV. Okay, of course it will be very hard for him to estimate the specific value of the spillover. Yeah, that was actually in a sense the closer or the more narrow approach to research cooperation. That's what we will also have in a tutorial class, where we will have problem sets or assignments on that. There's, however, a more extensive discussion about that. And again, our example from CureVac and the fact that the government pays something and subsidizes this shows you that here some cooperation might go on. And this cooperation and on this idea of the cooperation in a whole economy is put in terms of the notion of what is called a national system of innovation. And that's what is also related to what is called by researchers here. This is based on Furman, Michael Porter and Scott Stern, on what is called national innovative capacity. And what is this national innovative capacity? It's the ability of a country to produce and commercialize a flow of innovative technology over the long term. Okay, and on what does it depend? It depends on the strength of a nation's common innovation infrastructure and the environment for innovation, and that's what I write in the notes, in the national industrial clusters, and the strength of the linkages between these two. And what you see here, and what is really interesting in Germany, and that's what's interesting, that these American authors stress this, there is some intermediate segment which, in a sense, provides the link between the public sector, the government and the universities and so on, and the private sector with the industry, the various industries. And this interlink is, first of all, the vocational training system, okay, unser Ausbildungssystem in German, duale Ausbildung, we would call that dual education and vocational training system, and the Fraunhofer Society. Fraunhofer Institute, the Fraunhofer Institutes are just institutes which are run jointly by, say, the government and universities and by the industry. Okay. And what you see here, there are many connections, once in a while direct connections between universities, and in particular technical universities, and for instance electronics or the software industry and the chemical industry, also Max Planck institutes, which are more purely scientific, in a sense basic research oriented. They also work together with some industries, in particular the chemical industry. But you have these connections between, and you see, even though there are so many linkages, I draw additional ones here. And so it very often works via the Fraunhofer Institute. Okay. And in terms of the Fraunhofer Institutes, we have one of biotechnology or bio-insect technology here at JLU, at the intersection of Aulweg and Leihgestener Weg. If you happen to see that, this is a rather new building because it was just recently established. Okay, and you see this is the kind of cooperation we have here between universities, between companies, and government funded typically. And what is of course important here in that respect is how important, for instance, public basic research is for firm innovation. Many, for instance, pharmaceutical products have been developed in universities or in public hospitals, and then or invented and then further developed in the private sector. Okay, that's where it's important. In the US, the situation is slightly different. You don't have this intermediate part here. Okay, you have the university system, you have many institutes like the National Institute of Health, which provide a lot of funding and input to, for instance, the pharmaceutical industry. The Department of Defense is very important, and the Department of Energy. We also give a lot of money, for instance, to the aerospace industry, to the computer industry. ARPA, I think, was it ARPA or DARPA network? So the internet came all out from this Department of defense. Okay, and of course, in the end, we are interested how well these national innovation systems perform, and that's where Furman and Michael Porter and Scott Stern tried to come up with some measure, and their measure of innovativeness was the number of patents you get in an economy. Of course, you have to normalize that by the population. Otherwise, it's clear that the US has more patents than Switzerland. But what you see here is that, for instance, Germany would be blue here. You see it's still the Federal Republic, or it's Western Germany here in this part. This would be this year, if I'm correct. So you have an output of about 100 patents per million population. Switzerland, and if I'm not mistaken, this year has even higher output. The USA should be about here, so they also have a rather well-performing system, which is probably very much related here to their very good university system here. Okay, which provides also think of just Stanford University and so on, which provide a lot of input in terms of patents and then enable firms to develop these innovations further. And I think I have two final slides here. There have been various approaches to these national systems of innovation, and as you will see in the next diagram, authors have been very creative in order to produce nice pictures here. What you see here and what we previously saw in the Porter and et al. Framework, you had the government or a public sector, and the industry and academia was part, in a sense, of the public sector, and you had Germany this intermediate sector with the Fraunhofer. And here, what you see here in this approach from Etzkowitz and Leidersdorf, academia has its own role, in a sense, to play, and there's a lot of overlap here. And as you see, they produced a wonderful diagram here, what they call the triple helix, and what it means. At least that's what it should say, is that, in a sense, these three different agents, in a sense, reinforce each other. You get some feedback effect, and the important point is that the university can play an enhanced role in innovation in an increasingly knowledge-based society. Okay, so they say it's in particular important in a society which, like the German, which really depends on knowledge as a resource. And there, universities can play a key role and can foster research and development, and in particular innovation. Okay, that's what we pretty much have as the main result or statement from this kind of argument. I think I'm done here. This is already the next chapter. If there are any questions concerning all of our spillovers and of our externalities, we can both discuss them in WebEx right now and also in the tutorial class. I think the important part here about this lecture is really that you understand or are able to interpret these diagrams. And the important point is here, if the spillover is low, you have these strategic effect and commitment effect, which leads to overinvestment. Okay, if the spillover is high, you also have two effects. Okay, that's a problem. You have so many effects here. You have the positive effect of the spillover, that you benefit from your rival. Okay, you benefit from your rival because you learn from your rival. That's a positive effect of the spillover, and at the same time, you have the negative effect from the spillover because your rival benefits from you. In terms of the evaluation of whether cooperation is a good thing or a bad thing, you saw that it's key what the value of the spillover is, because if the spillover is low and if you don't internalize the spillover, it's just an instrument if you cooperate to reduce innovation and to solve this business dilemma. Okay, I think I stop here. Time ran out. As I told you, I'm available for further questions on WebEx. I thank you for being with me. Hopefully it was somehow clear, and we'll meet again next week. Thank you and goodbye. Okay, so hopefully you didn't have the same troubles I saw here or YouTube told me